So she started off by saying, hey, remember this stuff. Here's tangent inverse. She gave us sine inverse, but I don't think she used that one. I guess she's showing the difference between them, that sine has the square root and a minus sign, and tangent didn't. She didn't really explain much. She just said, hey, remember this, you might use it. And then in this example, I don't know why I called it later example, but I guess that's just sort of how she finished it. And she ended up with long division with this integral, which was not the natural log that we've been working with. It is, oh man, where's that note card of arctangent and arcsine? And because I told you we were going to revisit that later and use it, and now we're here at later. So on that note card, you might want to find it and use it for this kind of sections. And then we're really going to focus on memorizing some of those rules, like in our review right before the exam. So I'll probably even let you use that note card on this test, because they're so similar, and I'm more worried, can you use it? And then if you would have memorized it for the exam, then go for it. So this looks like just regular arctangent, nothing special happening here. She did the special stuff in the second video. So she's trying to see if you can see these two together. Something squared plus something squared. The u is the one that goes with the x, so it goes here. And then I pulled the 4 out. She pulled the 4 out. We both pulled the 4 out to get this particular one. So the first video was more like review, had long division, natural log, and then this little blip of new stuff. Yeah? No, you don't. Oh, yeah. So we're gonna make sure we have, and in the book it's got it all written out pretty in a chart. So if you peeked at all at your book for this section, which is 4.7, they have all of the arc ones right here. So arc signs at the bottom. It's really little, but you've got it in your book on page 357, where they have A and U like she did in the second video, and where to put it, and the 1 over A for arc secant. So that's all here. You probably want to add that to your note card for future. Okay, too many notebooks. Oof. So I do want to talk about complete the square and see if we can do that all by itself, so that her instruction will make more sense. Because she started out with some harder problems right off the bat with the square root of 5. I mean, our book doesn't do anything like that until you practice like the straight up definition a couple times. So let's take a look at complete the square for 4.7. And you didn't like it in Algebra 2. You were okay with it in pre-calculus. Now you're just going to be like, okay, that's no big deal. So we're in 4.7. It's called inverse trig integration. There are some topics that you sort of gloss over because they don't seem all that important, but I've seen a question on an FRQ with inverse trig in at least like 2 of the last 4 years. So that seems like, and it wasn't last year. So it seems like something that you might see. Well, I don't know that it was last year. I didn't see all the questions. I just saw the ones I graded. Anyway, so let's do complete the square first. Complete the square. And she did that, but it went really fast. And all of her math just sort of popped up there like magic. So if you had something simple like x squared plus 4x. In Algebra 2, we said, what's the c value? And we thought about what it would take to say this is something times something else to make 4. If these two things are the same, what would it be? X plus what? 2. And she reminded us that if we took b and divided it by 2, we would get this value. So it would be x plus 2 squared. That means the c value has to be 4. Okay? And when we did this with complete the square in Algebra 2, we added it to this side and then we added it to the other side. But we're not doing that in the trig stuff. In the trig, we have to make it 0. We have to account for this plus 4 by also subtracting 4 somewhere else. So we're going to group up a quadratic that we can complete the square on, and then we're also going to have the minus 4. So in our arc trig analysis, there's like something squared plus something squared, or the square root of something squared minus something squared. So if we add 4, we have to subtract 4. That wasn't enough. Let's look back at some of the problems that she had, just because you've already done them. So she had this one. She had the integral of 8 over the square root of 1 minus 50x minus 5x squared. And she'd already told us to remember that the integral of, this is from her first video, du over a squared minus u squared equals sine inverse u over a plus c. Okay, so she'd already told us that, a little piece of information. So we look at this, and first we think, can I take the bottom and make it the square root of u? That would be our very first section on u substitution. If we make this u and take its derivative, we don't see 10x anywhere plus a number. So that won't work. Then we think, well, the next thing we did was division or the natural log, and that won't work. But that square root and squares makes me think an arc trig function. So for right now, pull out your little note card and think, I need to make it into something squared minus something else. 1 is already squared, but that doesn't help me with the 5. I need to somehow take care of this guy. Okay? So what you want to do is complete the square on these two things. And this has a minus in it. I think they all have a minus in it. Do y'all have your cards? Except for tangent. When they're in a square root, they're all a minus. So there's that minus there. So what we're going to do is maybe over here on the side, we'll look at 1 minus 50x minus 5x squared and see if we can complete the square on this piece. The 1 obviously doesn't help us any. When we derive the quadratic formula, and I did that for extra credit for you guys and said if you can derive it, then there's extra credit for you. The first thing we did was divide by a, because we can't have a square if we've got that 5 in the front. So the first thing that she did was said 1, and then she took out the 5, and this is for the part of the equation that has a minus. And then that leaves us with what? 10x plus x squared. And then now this looks like something easy to complete the square on. Maybe it's even easier if I write it like we're used to seeing it, x squared plus 10x, and then leave a space like that. So now I'm going to say, instead of this, what am I going to write in the squared part? Plus 5. So plus 5 goes here, and then what goes here? 25. So then you look at it and say, okay, I've changed my equation. 25 was me changing the equation. We put it in a square so we wouldn't forget that we did that. So we have to undo it. It's not cool to just randomly add 25 to math equations. So how do we fix it so we didn't really change anything? So close. What did we really do here? We added 25, but if you multiply this all the way out, it's multiplied by -5. So that's the tricky part. So add 125, because this is really minus 125, so we have to add 125. So if you missed that in the video, because it really did happen really quickly, then we really have 126 minus 5 times x plus 5 squared. So now we have something minus something without the dude in the middle who messed us up. Yes. So if we took this whole equation and multiplied it out, we'd have 1 minus 5x squared minus 50x minus 125. Like it's a minus 125 that we added, that we included in the equation. So we didn't add it. We minused 125. So we have to add 125 so that we get 126 minus 125 gives us the one that we started with. Does that make sense? Okay. So you have to consider that these go together and draw all over your paper, whatever you need to do until you get to the point where you have something that you're going to work with. So what our goal was here, this was our goal, we met it. Our goal was to have something minus something else that we can undo for our trig function. So let's look at this again. I'm going to write it as 8, or I could take the 8 to the outside. Are y'all good with that? If I multiply 8 times the integral of 1 over the square root of this, okay, this was all in the square root, so 126 minus 5 x plus 5 squared dx. And now what I'm trying to do is say, okay, well, if this is the formula for sine, and this is what I have, which one, this is supposed to be an a, which one is a in the a squared position? So we write a squared equals 126. A squared equals 126, and figure out what a is. Exactly, which we just leave it. We don't need to simplify it. So we found a. See, this equation needs an a. We got to throw an a in there. We got to figure out what that is. And then we got to figure out what u is. So we also can do what? The whole thing. The whole thing. So this is a, and this is u. So u squared equals 5x plus 5 squared. Which square root, and we're taking just a positive version of it because we need it to be negative up here. That's going to be the square root of 5 times x plus 5. And now we've done all that work. We're really thankful to have that card and say that the integral is 8. Don't forget the 8. 8. And I missed the part. Oh, yeah. I didn't do that yet. Hold on. Don't do that yet. Erase your 8. So this is not plain Jane. If it's not plain Jane, we have to do u substitution. So we need to say du dx right here. And if we multiplied this all out, we'd take the square root of 5x and take that derivative, we get the square root of 5, right? So it affects, it's a scalar multiple in my problem. When you rearrange this guy, you get du over the square root of 5 equals dx, which means that if I replace u with this, I'll write it pretty. Here it goes. Because I really don't want you to miss it. If I write it pretty, it's going to be 8. The integral of 1 over the square root of 126 minus u squared. Because I replaced u with this and I squared it. And now I'm going to replace dx with du, so it's going to be du over the square root of 5. And now, go ahead, Charlotte. So now you put it with the 8, and your answer is 8 over the square root of 5, and then you write out the arc sine stuff. Arc sine of u, so u is this, over a. Plus c. Don't forget that plus c. Of all the things, that's the easiest. I don't have a whole lot of years of experience with the AP exam, but the readers in my group say that sine, cosine, and tangent are the ones that are most frequently used. And tangent is arguably the easiest. Tangent's not usually my favorite because it seems harder for a lot of reasons, but as far as arc sine and arc tangent, here, this paper, this one is easier because it doesn't have a square root in it. So for me, I would hope for arctangent because it has one less thing to think about. So having redone her example, it's up there. I think she could have done some simpler ones to start with. I felt like this was more review for people who'd already seen it. So I apologize. I should have probably taught it first and then had this be review, but it gives us something to look at. Do you feel like you get that now? Could you come up with it on your own? Okay. I could with the card until I did a whole bunch with the card right now and got it straight in my head because remembering to go DU it after I'd done all that other work felt like extra work, but I needed this in the front to fix that scalar multiple. Okay, so she also had a tangent one. Do you want me to go through her example 3? So she's got 2 more, and I can do them slowly. The one that was tangent, because it's no square root, and then this one was also tangent, I assume, because it, doesn't have a square root. You want to go through those slowly? Yeah, okay. Then we'll take a look at some practice problems from your homework. Your homework's going to be beginner level, get a little bit harder. So I would consider this high to intermediate expert level. Okay, so those examples, yep, yes. So here we go. Example 3. Of her example 3, I'm going to name it the same thing. She's got the integral of 3 over x squared minus, it's really minus 4x plus 9. So it's a rational function. You're not going to do long division because there's nothing big on the top. You don't have the derivative on the top, so it's not natural log. It's probably one of your arcs. It's tangent. Yay, the easiest one. So we need to complete the square on the bottom. We're looking for it to be du over a squared plus b squared. I lie. A squared plus u squared. For it to be, oh, I've already got du. She writes it on the top. I'm used to writing it on the side. My bad. And then our derivative or antiderivative of that is going to be 1 over a. That's the part that I just did a minute ago where we found a was something different. It's just a formula you can memorize straight up where we have tangent of u over a plus c. The u always being the one with the x in it. So this is pretty much ready to go as far as complete the square. What can I say? I'm going to put the 3 on the outside so that I have that 1 over look to it. I'm not completing the square with the 9. How do I complete the square with the negative 4? So x minus 2 goes here. That means if you multiply that out, we'd add 4. So what else do we do? Subtract 4. So I don't know how you want to do your notation. Maybe you take an intermediate step where you write out the entire complete the square trinomial. But in order to have this, we'd have to have x squared minus 4x plus 4. Now it factors. 9 minus 4, I can now write as 5. I was going to add it here, but I wrote it on the part above. And now it looks like something squared plus something squared. Even though this isn't really a square, we can make it a square by just calling it the square root of 5. So you're going to say this is u squared and this is a squared. That means u is equal to x minus 2 and a is equal to the square root of 5. And if you write down this formula that has the 1 over a in it, you you don't have to take the derivative. So the derivative doesn't show it up here. That's just part of the equation. Yeah. So thank goodness they have that as part of our equation here. No, they don't. That makes me look. Oh, because it's tangent. Tangent. Okay, they do. All right, so then we just can fill it in. We know a is the square root of 5. Tangent. U is x minus 2. A again, the square root of 5 plus c. Tangent inverse. Either write arctangent or tangent inverse. And I forgot my tangent inverse. Don't forget the tangent inverse, Leland. Oh, and the 3. The 3 up here. 3, 3. Thank you. So this one's way more straightforward. Don't forget the 3. Okay, then this one has one more little touch of fun to it. This is her one she called extra practice, so that's what I called it, practice. The integral of 3 again. 3. And then we've got 2x squared minus 4x plus 15. So take a second. You complete the square on this. You're going to need to take the 2 out. Okay, so we want to take the 2 out. We just want to complete the square on this. We're going to leave this as the a squared. And so, well, this will be changed, but this is going to be part of our a squared. So if we take the 2 out, we can complete the square here with a 1 in the front. That's important. This will be 2 times x minus 1 squared. So this will be plus 1. Together, this is plus 2, so this has to be minus 2. How about that? Okay, so that makes my problem really 3, 3, 1 over 2x minus 1 squared plus the square root of 13. So u squared is this guy, 2x minus 1 squared. Therefore, u itself is the square root of 2x minus 1. A squared equals, and I wrote the square root of 13 because I was thinking ahead. I'm sorry, it's just 13. A squared equals 13, so A equals the square root of 13. Sorry, better? Okay. And then I've got a dx here. Well, u doesn't have a 1 derivative. So I'm going to have to turn this into u squared plus the square root of 13 squared in order for this to work. And if I change this all into u, I have to consider this has a derivative. It would be u prime would be the square root of 2. So it goes, if I rewrite this with the du dx notation, it'll be du over the square root of 2 equals dx. So what does that mean? That means, if I rewrite it one more time, I've got 3. 1 over u squared plus the square root of 13 squared. So that I have the formula looking of inverse tangent. And then instead of dx, I have to write du and put the square root of 2 over here. Now it looks ready to go. This is my scalar multiple, which I'm going to keep 3 to the square root of 2. Then I'm going to say the tangent antiderivative is 1 over a inverse tangent u over a. So I need to include 1 over a right here, and then arctangent, and then put u over a, which ends up being the 1 over 26 that I had, the 3 over 26 up here. They're both in the same house. You can multiply them together. You could leave it like this because the AP exam does not need you to multiply things out, that you can multiply things out. So if you're stuck here and you're like, do I really multiply them? I'm so tired. Just leave it here, okay? Perfectly fine. So these were, I really think these were hard ones. They are much harder than you see for your homework. So if you're following this, you have things to look at, and now that we've gone through them, hopefully they make more sense. I think your homework should be a breeze. But let's look at some of the way the questions are asked, just so you're ready for them. So here's the beginning of your homework. They pretty much are ready to go. They have like the square root of 1 minus something squared. You should be able to pick out A and U pretty quickly and write this out. So this is just you using your note card, getting familiar with the antiderivative, and maybe dropping the note card because you've done several examples and feel good about it, okay? Then there's some where you have to complete the square, and it says complete the square, and they're really not as complicated as we just did. And these are definite integrals, so when you're done, just plug in the numbers, see what you get. If you have trouble with arctangent or arcsine, trying to figure out what to plug them in, then, you know, ask me, we can go over it tomorrow. You can use your calculator. On the exam, if you get to this step where you're plugging stuff in, if you leave it as arcsine of 1 minus arcsine of the other one, 2, and just leave it, that's good enough, because that's math that you can put in a calculator and figure out. So I need you to know the unit circle and use it a lot. Using the inverse was harder, and we did that in remote learning. Maybe you just need to just leave the math ready to go, okay? And that would be okay. So we'll talk about that as you work out the answers. On your calculator, just as a reminder, if you're plugging it in to look at it, it says arctangent, like that's the blue and then the tangent button. That does mean tangent inverse. So you could actually say tangent inverse and plug in 1 and have it tell you an answer. If they want the answers with 3 decimals, you can plug it in. That's not that hard. How does this go in here? This way. Oh no, I forgot how to work my calculator. Okay, there. And then let's see. Then there's 2 problems, I think, that say find the area of the region, and they give you this equation. You have to find the area. What does area mean? It means slap an integral on there. That indicates find the area of this. So you would say integral of, and then this looks like sine. Okay? So I feel like that's pretty straightforward. And then there's a couple of FRQs, which are also, if you can do the problems we just did, these these multiple choice are a breeze. Okay, so good job. You've got 15 minutes. I'll put a book up. You can get started. The first ones are really straightforward. And I'm going to work on these in post solutions at some point. I don't have them already done, so you can check for Calc Chat until then. 4.7. This is page 359. And your problems are 6 through 11. And then 27 through 31 odd. And then these problems, 55, 57, 74, and 75. So once again, it is page 359, 6 through 11, 27 through 31 odd, 55, 57, 74, and 75.